Now students, will see number 3 type of reaction in much more detail, that is about displacement reaction, which I discussed in earlier class. Okay, so you can see here A and B, C is about to react, and to remember, A is more reactive than B. A is more reactive, B is less reactive. Therefore, A being more reactive will displace B out, and we get AC. So displacement reaction is those reactions in which one element which is more reactive will displace the element which is less reactive, that is B, from its compound. But how I came to know that A is more reactive than B? Okay, that is with the help of activity series. So this series you have learned in class 7 also. Now in 8 also you will be learning, even in 9, even in 10. So this series is important for class 7, 8, 9 and 10 students. So do remember, activity series is a series in which metals are arranged in decreasing order of reactivity. I repeat again, and you can repeat the video if you want. It is a series, define activity series. It is a series in which metals are arranged according to decreasing order of reactivity. The metals which are highly reactive are above, and the metals which are least reactive are below. So if you see here in copper and zinc, which is more reactive? You have to remember this series in sequence by heart: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, silver, and mercury and silver. You have to remember this series by heart, okay students? So now in this series you can see copper is here somewhere and your zinc is here. So which is above? Obviously zinc is above. So therefore we came to know zinc is more reactive than copper. So always remember who is more reactive than who is, we come to know from the activity series. So here zinc is more reactive than copper. Why? Because zinc is above in the activity series as compared to copper. So whenever zinc reacts with copper sulfate, you know that in these two, which is more reactive now? Zinc is above, copper is below. So zinc is more reactive than copper. Therefore, zinc will displace copper. Zinc will displace copper, students. And as zinc will displace copper, copper will come out. And we get here is zinc sulfate. So it's a displacement reaction where zinc is above copper, so it is more reactive and displace copper to form zinc sulfate and copper. Similarly, the second example of displacement reaction, you can see again. You have to remember this activity series by heart, okay? You can see hydrogen is somewhere here, whereas potassium is above. So that means which is more reactive? The one which is above are more reactive. So this potassium is above, it's more reactive. So potassium is more reactive than hydrogen because hydrogen is below. Therefore, potassium when reacts with water, it displaces hydrogen out. Okay, it will displace hydrogen out and we get is KOH. There are two hydrogen here, right? So KOH is here, then one hydrogen is left, which is here, and then after it can be balanced. So do remember in both this example what you see, if you remember the activity series, zinc is above copper, so zinc is more reactive and displaces copper from copper sulfate, forming zinc sulfate and copper. And in this case potassium is above hydrogen, so potassium is more reactive, so it displaces hydrogen. So which is more reactive than the other element, we come to know through activity series. So you have to remember, students, simply this activity series in detail. So what you will do is definition of displacement reaction, you have already written even the examples. Okay, now here you have to remember the definition of activity series, and to remember it is a series in which elements are arranged in decreasing order of reactivity. It is a series in which elements are arranged in decreasing order of reactivity. The one which is above are more reactive than the one which is below. So the one which is above are more reactive than the one which is below, that is copper and hydrogen. So therefore zinc will displace copper and potassium will displace hydrogen. And in these two examples, if you have to remember the example of displacement reaction, I will always say to remember the first one, because first one is easy, no need to balance, it is direct. So remember the first example as compared to the second. But do remember both are the example of displacement reaction, students. So if you want, you can repeat the video. Thank you.